So I'm Jev. I'm a staff decision scientist at Vinted. And it's nice that my colleague Lucas has already alluded to the topic that I'm going to talk about. Our product is quite complex, and there are many different teams that are working on this product. All of these different teams introduce changes into the product, and we want to know the impact of these changes on our members and on the particular business metrics that we might be using. The things that I'm going to talk about today were not built just by our experimentation team, but there are many people across the time that Vinted has been alive that have been building these tools, and our team has been just building on top. So it really emphasizes one of the core values of Vinted, of working at Vinted, is co-creation. And a lot of the things that I'm going to show you today have been co-created together by different teams and people at Vinted. So once again, this is our experimentation team. Some of these people are here today, so if you'll have any questions, you can ask around as well. So let's talk specifically, what do we mean by experimentation? So here's our app. And in fact, this is a test for a recommendation system. When we roll out a new recommendation system into production, we have a control group, which has the old version of a recommendation system, and we have the new version of a recommendation system. And we compare the control and the test group given on a different set of metrics. In this case, this is actually not comparing all the new recommendation system. In this case, this is moving the recommender feed on top of the main page at Vinted, and then comparing that against the control group and seeing what impact would that create on business metrics. And at first, it might seem, yeah, this is a great idea. Let's just move the recommender feed there. But actually, there are a lot of competing objectives at Vinted. There are different monetization streams. There are different channels that members can search for their items. And all of these things can interact, creating outcomes on the metrics that we're measuring that we might not expect. And it's exactly the case in this test as well. Now, there might be other tests in the case of ads, where our ads team might try to place an ad in the carousel of on the item page, where they might place an ad after the last image on the item photo carousel, and then they would like to see, does that create more ad revenue, and does it hurt or not hurt other core business metrics? So they would, again, create a control group, which does not get this change, and then they would create a test group which does get this change, and then they would see what happens in that case. So doing that requires quite a lot of infrastructure to support it. There is another change that, just to give you an example, these changes might come from safety, just to protect our members from potentially adverse agents on the platform. These things might be tested as well. And we have teams that are proactively introducing these new changes and comparing the control and test group to see what impact it might have on our members safety, as well as on our core business metrics. So all in all, Vinted is a very, very complex system. So on the left for you, we have the marketplace. So you can imagine all different green dots are people doing transactions with one another, viewing each other's listings, and there is a very complex dynamic that is happening there. While on the right, you have us, employees like me, who work together in teams trying to introduce different changes, hopefully to make the experience of our members better. This is a very complex system. There is a lot of interconnection, and the only reliable way to test what is the impact of changes there is to perform an A/B test. Now, A/B test is only the simplest way and the most known way to test changes. Because we're a marketplace, we actually have to support a lot more different experiment types than just an A/B test. So for example, now there is a discussion to do a encouragement design test, which is something used a lot at other companies where we cannot have control and test group, but instead we roll out a feature to all our members, and then we randomize on who gets the communication and who does not. And then we can use statistical methods to infer the impact on the core business metric given who received or who did not receive communication. This is called instrumental variable analysis. There are a few more different tests that we might use in practice because this is a marketplace. Every different member, when they interact with a new change, they actually impact every other member. So for example, if you buy a particular popular pair of jeans, which is of extremely nice quality, and these things, as Lucas mentioned, might be gone on the first day, you make that pair of jeans not available for another customer. So that means if that customer was in the control group and you were in the test group with the new recommender system, that means there is interaction between control and test groups, and we call that interference. So that might bias the results of our analysis, and therefore might bias the result of our decision making. And this is extremely important because, as was mentioned in the previous talks, there is a lot of deployments, there are a lot of new changes that happen. So if these changes are not based on accurate measurements, we might have false positive, we might have wrong decisions, and we might actually not be improving our core business metrics and the experience of our members. So this is why testing and experimenting as much as possible is really important, and it's especially important for marketplaces because of all of the complex interactions there. So to kind of illustrate what that means for different product teams, and not just product teams, we know that changes also deep in the backend and infrastructure can have down-the-line consequences on the member experience. Everything needs to go through identification of opportunity, prototyping a solution, and then running an experiment as soon as possible, looking at what impact it has on our member experience, and then refining that idea given the results that you get. And teams iterate on that as much as they can. And I will be showing some statistics towards the end of the presentation just to get an idea of this. Now, to support that process that I've shown you on the previous slide, there is actually quite a bit of internal tooling that has to be built to support engineers, designers, product managers, data science, and decision science people in making their decisions. So we have to have a compute and analysis engine that takes all of our core business metrics and analyzes them. We have to have statistical packages that are appropriate for the job. We have to have metrics documented and stored so that we know which business metric to compute when. And we have to have the randomization engine and the experiment setup process. And all of that, on top of it, has to have, so to speak, social features that allow people to actively explore and contribute changes, the necessary changes to this experimentation platform. And all of that has to, again, talk with our product and also has to speak to our data warehouse to know which business metric to compute and when. So let's go through an example of an experiment setup and how that might look at Vinted. And while we're going through this example, there will be clear illustrations that I will be alluding to that still need to be improved in order to increase that experimentation velocity so that we can go through the circle of experiments, the ideation and deployment as fast as possible. So here is an example where we are testing placement of different elements on the newsfeed. Now you might imagine that the key thing here is that we cannot test different placement at the same time. We create 3 groups where we do the placement of the newsfeed at different locations on the page. And we cannot have a member see the same placement at the same time. So we have to create actually multiple groups and make sure they are isolated when we run these experiments to check the business metrics. So an experiment might look like this. In our case, we will have a parent experiment which randomizes members into of A and B group. And then each of these variants, so of A and B, these are called variants of the experiment, each of them will have an experiment within itself so that we can compare one placement C against the off group, where there is no change, the status quo. Then we can compare the variant A against the status quo, and we can compare the variant B against the status quo in off group. So this allows us to establish what might be the best place on one of our main landing pages on Vinted, and what might be the interaction of our members with this. So this is a relatively more complex experiment. So how it would look in practice, that on top we have all our members, so 100%. Then in the parent test, we have to split them into thirds of the whole population. And for each of the third, we then do a 50-50 split again. and then we compare different variants within it. So this is one of the more complex experiment design setups that we have to support. And when it is this complex, it's easy to make mistakes. So we have to also support teams in doing AA testing really quick, where they set this up, they set up the randomization, but they do not introduce the change just yet, but they let it run, they collect the events, and they see if there is a difference or if there isn't a difference between business metrics. And this allows us to make sure that, indeed, that the randomization works properly. So how it works from the code point of view, we would have first a check if the test is, so on the top is how it would look usually for a simple test. On the bottom is how it would look for a more complex test. So we would check if the test belongs to a particular variant in the parent group, and if yes, then we would check what variant it belongs into in a child test. So this allows us to create hierarchical structure, and this logic would be somewhere in our code in the app to check what should we serve to our members, and then measure what kind of interactions they would have with it and what business consequences and member experience consequences this would have. Now, there is a lot of room for improvement here already, because at the moment, engineers have to do it by hand, when instead we should be working towards creating very effective and configurable feature switches. So in the end, we need to unify this logic. So this is one area for improvement. Now, once that is done and the code is already with our members, the randomization engine turns on. And this is just a pseudocode of what it looks like. We get the test name or test salt. We get the member ID, and we randomize them into buckets using hashing algorithm. And then each of these buckets is attributed to a specific variant. And we use that logic to do kind of very reliable randomization of members into different variants. Why this is important? Because the reliability of randomization engine really makes your statistics valid when comparing different groups. So it's really core that this works extremely fast and that this works very reliably. And the different companies have been investing a lot into making sure that this works, and so have we. Now, once this code is written, or even before this code is written, someone has to configure this experiment, explain where it's going to be running, and what is the purpose of this experiment. So we've built tooling internally for that. We have an internal system that allows us to see which experiments and when are scheduled, what type of an experiment, which different teams are running these experiments, and who is the experiment owner. This allows us to track what changes are being done and also to report what is the cumulative impact of all of the different changes that we are doing in our product. And we'll get to that in a second. So let's suppose we're trying to create a new test. We create a new experiment somewhere in the item page. We would set the portal and the country where the experiment is running. Sometimes you might want to run an experiment in one country, but not in another country. It all depends on the realities of kind of business context. And then once people configure this experiment or create this experiment instance, they need to say, what is this test about? So let's say this experiment is about search experience. So they would have to define what is the strategic opportunity, what are they targeting with this experiment, so that this knowledge is institutionalized and at any point in time we can recover. For example, 6 years ago or even 7 years ago, testing video features on the platform might have not worked. But and we actually have it tested a long time ago, but now video is doing a comeback because of just members expect video. So you might use the knowledge in the past to see what impact video features might have on your app now. So you want to institutionalize that knowledge and save it for later. Also, experiment owner specifies the target metric. What is it that they're trying to improve? And this might be business metric. This might be something like latency as well. They have to specify the hypothesis. So this is just like in the clinical trials. And they also have to specify what metrics they are targeting. And I'll talk about it in a second. We've standardized and are in the process of standardizing around 480 metrics already at Vinted. And so these are kind of just to give you picture of what these metrics might look like. The first half of these metrics is blurred for obvious reasons, and then at the bottom is the decision support. So this is where the experiment owner has to specify how they will be making a decision given the experiment result. Oh, this is just repeating that there is text there. OK, so now about metrics. So we have an in-house built metric standardization package. So here is an example. So it's a very similar solution the way people have built it at Microsoft, Netflix, or LinkedIn. It's an internal metric definition setup where we use Python objects to automatically generate SQL that contains the metric definition logic. So here is an example of a sell-through rate definition that then generates a particular SQL query. The reason we want it to be quite flexible is because there might be arbitrary join definitions that we will be using when computing a specific metric, and this is depending on the kind of result that we want to report. And this allows us then to reuse this for, in general, metric calculation, because then we can abstract away a lot of statistics using that and perform it right on the data warehouse. And that would be a lot more efficient than doing it in Python. So this is how the metric definition looks in practice. So let's say sell-through rate. A decision scientist or a data scientist, whenever they want to create a new metric for a business, for their product team, they would go ahead and define this metric. So all it takes is to define a method getMetricMeasures and provide a docstring that we then use to surface all of these different metrics for our product managers and business decision makers, engineering managers, to know what a particular metric might mean. So all of this is held on a GitHub repository in a standardized manner, and we can maintain the metric quality that way. And then we surface all of these metrics and make them discoverable, since we have a lot of them, for our business decision makers. Not even business decision makers, we want to make it as easy as possible for anyone to launch the experiment. So that is why all of that knowledge that our decision scientist or data scientist might have has to be written down and can be discovered by anyone else. So then computation engine and the results. There is quite a bit of interesting statistics that happens in the background. The way we've built it is that we have different Python libraries that use the metric standardization package on top of it to perform different statistical analysis. Anything from basic linear regression to something more sophisticated like instrumental variable analysis or variance correction. So these are different methods that allow you to perform different analysis depending on your situation. One of the most known things is a thing called Cupid, which is a variance reduction method. It allows you to shorten the experiment time for you and therefore make a decision, make decision a lot quicker. So all of this is just packaged into Docker and run as jobs every day to compute different results. Now this is how the results look like. So this was built by our colleagues to show different statistics for different experiments that might be running. So on the left, we have different business metrics. And like I said, we have more than 400 of these different business metrics, and also performance metrics that we compute for different changes. We also have our results for different countries, as well as the results in aggregate. And what you see, the green and one red cross there, is a thing called sample ratio mismatch. So this allows us to check automatically the quality of experiment, if it's reliable for decision making or not. So we have to do all of these quality checks to make sure that the experiment indeed has been implemented correctly, because if it has not been implemented correctly, we cannot trust the results for the analysis. There might be some sort of bias. Now, at every different business metric, we can look at it in detail as well, look at the results of that metric changing over time. This is just to detect if there is a primacy or novelty effects there. So let's say you put a new button on the page, and people just might be clicking on it just because it's a new button. That doesn't necessarily mean that this improves their experience or improves business metrics. So this is kind of the utility tools that allows people to not have to wait for decision scientists or anyone else to do the analysis by hand. It allows people to just quickly check the results every day as soon as the experiment launches and make a decision as soon as possible. So where does us lead this next? So let's look at some interesting statistics, as I've referred briefly before. What you see on the top is a histogram of different uplifts for experiments at Microsoft. What do I mean by uplift? So this is the change between the control group and the test group. So let's say if you improved sell-through rate with your change, or you have not improved sell-through rate. If you even improved latency or have not improved latency. If you improved listing experience of a person or you have not improved. So this is all written in percentage terms. And we see that it is quite concentrated around 0, and it has a very long tail. So what it means is that changes that bring a lot of value to your members are exceptionally rare. And we see this exactly the same situation for data at Vinted. So this is also a plot of hundreds of experiments done at Vinted, and we see that it has very similar distribution. There are a lot of changes concentrated around 0, and there are very rare changes that actually bring a very huge positive uplift to member experience or some performance metric. So that has direct implications to scale rates. So how often do you find a change or improvement to a product that actually leads to improvement in member experience? So this is scale rates in industry, and our scale rate is about the same. That shows you that only about 10% of all changes that are made at Netflix may end up being in production. Because all other ones, all the rest of the 90% that they've tested, that they've done for different changes, have not met the business or the performance requirements, or were just outright negative in terms of their contribution to product experience. So this is why as many things have to be experimented as possible, because the underlying statistics show that it's just really hard to improve a very mature product. So this is another illustration of what that means. This shows how many experiments should a team conduct to reach a particular cumulative uplift. So we can see that if a team, zoomed in on the bottom left corner, if a team only does two experiments per quarter, per month, or even per year, there is very little improvement that they can achieve, given these underlying statistics. So we have a pretty good knowledge of how much we need to experiment to achieve certain business goals. And to enable our teams to achieve these goals, we have to keep developing our internal tooling to enable them to experiment as much as possible and ideate as much as possible and spin the experimentation circle as fast as possible. And what all of it illustrates is that it's very hard to assess the value of an idea. Sometimes we might be very confident that, oh, we just do this change in the back end or front end, and this will lead to good outcomes. That's not necessarily true. Small changes can have very big impact. And for this reason, as I showed you before, because big impacts are very rare, companies like Airbnb do 20,000 experiments a year. And that means that for any product team, for any engineer, for any designer, for decision scientist, or product manager, it should be extremely easy to launch an experiment. So that is why we have to build a really, really good internal tooling. So where the statistics, the setup, and the analysis are completely automated. So at the moment, we do around 300 to 500 experiments a year. And this is nowhere near to where industry leaders are. But we're on our way there. What do we need to do to get there? So we need to continue investing into our tooling infrastructure and automation, quality and trustworthiness of our metrics, of our data warehouse, resolve a lot of scientific debt, so keep improving the statistical models that help with the decision making, and keep improving the data literacy and experimentation culture. And then, hopefully, we'll be able to actually become the industry leaders, and we have already quite a few successes in that. Just last weekend, we traveled to Boston, and we did a presentation about some of the methods that were developed internally, and we had a lot of interest from some of these companies that you see on the slide, because, I mean, we are quite confident that we can get there. So that's all from my presentation, and hopefully you could join us and help us experiment towards the more sustainable consumption worldwide. Thank you.